Everyone, welcome to MrMath.com. Let's continue review on grade 9 math final exam. Okay, first question in terms of the polynomial you may be see in the final exam would be this question. Complete a table. Some terms is given here and question asking you to complete the table. I have the term here 4x. You know that the number in front of the variable called coefficient. So obviously 4 would be coefficient for this term. Therefore, coefficient here is 4. How about this term? The number which is sitting in front of expression is -3. Therefore, -3 is coefficient. Here I have another expression. As you see, I have -1. Here is -1. Yes? So therefore, -1 is coefficient of this term. 9 is a standalone, no variable, nothing. We call this term constant term. Constant term. In other words, 9 is coefficient for itself. How about the variable? This term has a variable called x. So x is variable. Here I have two variables. One of them is c. Sorry about. One is c, and the other one is d. The variable for this term, I have three variables here. Is x and y and z. Do we have any letter here? No, therefore no variable. No variable. Question number 2. In question number 2, question asking you determine or categorize each polynomial as a monomial, binomial, or trinomial. So in question number 1, the first part here, I have 1, 2, 3 terms. We call them trinomial. Trinomial. In this example, I have just one single term. Therefore, we call them monomial. Monomial. Here, next example, I have 1 and 2 terms. So therefore, we call them binomial. How about the last one? I have 1, 2, 3, 4, and 5. 5 terms is here. So there is no specific name for it. We call them 5-term polynomial. Type of the question you will be seeing is determining degree of the polynomial. Degree of a polynomial. Let's say you will be given a monomial 5, let's say x squared y. We are going to determine the degree of this. You know that to determine degree of a term, you need just simply add the exponent. So here the exponent is 2, but the exponent of y is 1. So if you add them up, would be 3. Therefore, this polynomial, which is monomial, the degree of this monomial is 3. Let's another form of the question be like 2x squared yz minus, let's say, x to the power 5y. First of all, this is binomial, and we are going to determine the degree of all these polynomial. To determine that, you learn that you need to determine the degree of each term individually and see which one has highest degree. So therefore, I'm going to determine the degree of the first term. The exponent of the x is 2, obviously. The exponent here is 1, here is 1. If you add them up, here degree is 4. What's the degree of this guy? This expression, I have 5, and degree is 1 here, therefore degree is 6. Which one is greater, 4 or 6? 6. Therefore, the degree of the polynomial is 6. Let's say you're being given this type of the question. Negative 2, A, B, C, and B in power of the 4 plus 2A squared B squared minus, let's say, 4AC plus 4B to the power of the 3 cube and 5, let's say. We are going to determine the degree of this expression, okay, this polynomial. First, individually, what's the degree here? Degree here, I have degree is 1, 1, 1, 1, and 4. Degree is 5. How about here? 2 and 2. Here, degree is 4. This term, I have 3 and 1. Degree is 4. Here, I do not have any variable, therefore degree is 0. Now, compare which one is highest? 5. Therefore, degree of this polynomial is 5. Next question is asking you to simplify the polynomial. To simplify the polynomial, you need to know the like term, determine the like terms, and then add them up or subtract them based on the sign that they have. So let us start with 3y. I have 3y here. Y, 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 another 3y I have here. These two together, you don't need to write them down and beside each other and then group them and then calculate for the final answer for each part. So just look at them and answer. You have 3y here, positive 3y here. Together, how many y you have? 6y. Okay, let's change the color. Y square. I have y square here, another y square here. So far, these two are like terms. Just search for y square. Do I have any y square? No. So just look at these two terms. I have 1y square here, negative 6y here. 1 take away 6 would be negative 5y square. Okay, we're done with these two. The next is, let's say, y cubed. So let's say go for the y cube. I have y cubed, y cubed here, another y cubed here. Okay, just look at these two terms, negative 4 and negative 2. If you add them up, negative 4 and negative 2 would be negative 6 y cubed. And then you have constant term. I have constant term here. One constant term is positive 7 and negative 1. Together would be positive 6. Always try to write the expression in standard form. It means start with highest degree and go for the descending order. So therefore final would be negative 6y cubed and then minus 5y squared and then plus 6y, and don't forget this constant, positive 6. This is final simplified term. Okay, next one. No like term for x, no like term for x squared here, and no like term for this constant. It means this polynomial is in simplest form. Okay. Okay. To simplify this expression, I have a monomial in front of a trinomial. So it's supposed to be expand inside the bracket. So it means this monomial is supposed to be multiplied inside each term of the bracket individually. 2 pi times this would be, you know that the coefficient here is 1. 2 times negative 1 would be negative 2p cubed, yes? And then 2p times 2p, 2 times negative 2 would be negative 4, P times P would be P squared. 2P is supposed to be multiplied to the last term. 4 times 2 would be 8. There is no P, so just write it down P. Okay? So we multiply. Next, we are going to multiply this negative inside this bracket. We have monomial here. Negative should be multiplied by this monomial term by term. Negative 3 times negative times 3 would be negative 3 P squared, and negative times negative 2 would be positive 2. And then how about for 4P? 4P should be carried down unchanged. Okay, let's go for the like terms. P cubed, I have P cubed here. There is no P cubed to be like term and match with this term. So as a result, just carry down unchanged. Negative 2P cubed. So how about P squared? I have P squared here, another P squared here. That's it. So let's calculate their coefficient. Negative 4 and negative 3 would be negative 7P squared. How about the P's? Let me change the color. I have 8P here. 4P here. Together, I have 12P. How about the constant term? We have only one constant term here in all expressions, so therefore would be positive 2. It is in regular standard form, therefore final answer would be this one. Okay, let's see what happened to the next example. In next example here, I do not have any coefficient here to be multiplied inside the bracket. In other words, I can simply drop down these brackets. So what remains for me? Just 3m squared minus 2m. How about this one? I have negative 2. This negative 2 is supposed to multiply it inside the bracket. Negative 2 times 5 would be negative 10m squared. How about this term? The last term has nothing to be multiplied. I just will carry this down. Positive 4m. Let's go for the like term. Do we have m squared? Yes, I have m squared here, m squared here, 3 and negative 10. 3m squared, negative 10m squared. If you add them up, would be negative 7m squared. How about m? I have m here and another m here. Negative 2m, 4, positive 4 would be positive 2m. So that one would be final answer in simplest form. Last example. Question asking find the algebraic expression for the perimeter of the following triangle. Perimeter, to find the perimeter, you know that I have to add up all length together. So therefore perimeter would be x plus 3 and then plus the other length or side is x minus 4 plus the last side is x. So this is the algebraic expression. If the question asking you to simplify, otherwise would be like that. So let me just continue to show the simplest form. So because there is no coefficient here, I can simply drop the brackets here and here. No bracket is needed. So x plus 3 plus x minus 4 plus x. Let's go for the like terms. I have x here, x here, x here. 1x, 1x, 1x would be 3x. How about the constant term? Constant and constant. Positive 3, negative 4 would be negative 1. So therefore, the final algebraic expression for perimeter would be this. Okay? All for now. If you find this video helpful, please just share with your friends and other students. and don't forget to subscribe, and we will continue the rest of the exam review in next video. Till then, goodbye.